Hello, everybody. Here is 2016 FRQ number 5. The question is about this funnel. I remember when this question was first of all came through on the actual 2016 exam. It was often regarded as one of the most challenging problems, and I really don't know why, because it's actually kind of easy. So here's the question. Inside a funnel of a height 10 inches, it has a circular cross-sections as shown in the figure here. The height h and the radius of the funnel is given by this function here, where h is from 0 to 10. The units of r and h are in inches. The question is to find the average value of the radius of the funnel. Well, that's pretty easy because you have a radius function here, so you just need to do the average value function of that equation. So average value is 1 over b minus a times the integral of a to b of the function, and the function is right here. So it's pretty simple to set up. The first point you get is for the integral, that's the green point here, and it says integral, so not integram, so you actually need the 0 to 10, and you need this entire function here. If you left off the 1/10, they would give it to you in terms of this first point, but everything else needs to be needed here for your green point. Then you have the antiderivative. So how are you going to do this? Well, 1/20th times 3 is 3/20ths, and 1/20th times h squared is 1/20th h squared. So the antiderivative, actually probably it's best to take this 1/20th and bring it in front because it's a constant. So that's where they're getting the 1/200th from. So the antiderivative of just the 3 then is 3h. Now if you do have the 1/20th in front of them, then it'd be 3/20ths h. That's okay too, obviously, if you didn't pull out the 1/20th. And then power rule, raise this to a 3, and then divide by 3, you get h cubed over 3. So this stuff here is needed for your antiderivative point. And then for your answer, it just needs to be unsimplified version or simplified version or anything of this sort. So as long as it equals the same thing, you can check on your calculator, you're good to go. So that's part A, average value of the radius of the funnel. For part B, it says find the volume of the funnel. So this is where students started to complain, like, oh my God, this isn't on a coordinate plane. We always do volumes on a coordinate plane. How am I going to figure that out? Well, just remember that whenever you're finding volume, all you have to do is find an area function. So as long as it's on a coordinate plane or not on a coordinate plane, you just need to take the integral of the area function. And since all of these things have circular cross sections here, all you have to do is find the integral of a circle, which is pi r squared. So the integrand is your first point, and then that is the integral from 0 to 10. Now this just says integrand, so if you left off the 0 to 10, they would still give you the point here as long as you have this with the square. So obviously that's pi r squared, don't forget your pi, and that's how you get that area function. So that's your first point. For your second point, antiderivative then, this is a little trickier, so let's look at how this is done. So I personally would put the square into both of these parentheses. So if you square 1/20th, you get 1/400th, and then pulling that in front, you get pi over 400 or 1/400th times pi. Then you have this, and that's a FOIL problem. So you have to write 3 plus h squared twice because you're squaring that, and you have to FOIL it out and get this. Now you can't really do this by like power rule kind of chain rule idea, because if you do this 3 plus h squared squared, the inside is not a constant. It's the derivative of the inside, the chain piece is 2h, so you can't just divide by the 2h. You really do have to FOIL this all out. And then, so that's just getting you started before you take the antiderivative, and taking the antiderivative of 9 is 9h, and 6h squared is 2h cubed. and then power rule raises to a 5 divided by 5. So it's just 3 simple power rule problems. And if you did put all of these over 400, that's perfectly fine if you didn't pull out the 1/400. Now the answer point here, any one of these, I would leave it like this personally, because number 5 is no calculator. Anytime you do these FRQs, number 4, 5, and 6 are always no calculator, and then usually number 3 is no calculator too, at least in the current exams. So I would leave it like this. Now, if you chose to simplify it, you obviously have that. If you accidentally used your calculator and gave yourself a decimal here, you know what? You should take off a point because you're not following the directions for number 5. So that's number B. That's letter B. So 2016, part C. So the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? Now, this is a related rates question, which are rare on FRQs, but with related rates questions, you're going to start with your good old, I distributed the 1/20th in here to get your R equals this guy. So that's your radius function. And then as you read this highlighted section, that is a rate. So that's going to be dr dt. And then this is like your question mark here. So your question is, what is the rate of change of the height? So that's your dh dt. So when you start related rates questions, you're looking at what's given. You're given a dr dt and you're given a dh dt. So you need an equation that relates r and h, which was given to you early on in the problem. And distributing this actually helps in this case. So how do you go from r to dr dt? Take the derivative. So that is the thing that's given. We'll get back to that in a second. So how do you take the derivative of this? Well, 3/20ths is a constant, that's 0. And then this is just power rule, bring the 2 in front, you get 2/20ths, or 1/10 when you simplify it all out. And then multiplied by h, because you lower the exponent to 1. And then don't forget, it's a chain rule problem. Whenever you do related rates, you need to tack on your dh dt. Now, dh dt is the unknown, so that's the thing we're going to be solving for. dr dt is 1/5, so you put in 1/5. But be careful here, it is decreasing. So it's actually a negative 1/5. That's a very common mistake. And then 2/20 is 1/10. The 3 comes from here, h equals 3. So putting a 3 in for h will give you 2 times 3, would that be 6/20, which reduces to 3/10. And then your dh dt is your unknown, and you multiply by the reciprocal to move this over the other side, and you either get negative 1/5 times 10/3 or negative 2/3. Now, if you didn't have a negative in your answer, you wouldn't get the answer point unless you said the surface area is decreasing at 2/3 inches per second. The word decreasing kind of takes over for your negative that you may have missed. How do you get your chain rule points here? So for your chain rule points, it's extremely important you don't forget the dh dt. That's what it means by chain rule. So if you made a little simple mistake in here somewhere and it's not forgetting the dh dt, then they might give you one of these two. But if you forget the dh dt, you pretty much are getting a 0 on this part C. And that is 2016 question number 5. Thanks.